Hi, I'm glad to see everyone here. My name is Dariusz, but if you used to use GitHub, you may know me as Keradus. I would like to show you some ideas, some good practices for the PHPUnit framework library runner, so we can enhance how we write our tests. This is kind of dense presentation with a lot of different topics, so we're gonna hop between them a bit. Hopefully we will catch up with everything. So first of all, what this presentation is not about. I will not try to convince you to write tests. I will not try to convince you to follow test-driven development. I will actually assume that everyone on this room already write unit tests and already know how to use PHPUnit itself. We will go deeper into it to discover how we can use it better. We will go through different stages of life cycle, how we treat tests in general. So let's start with the installation of the tool itself. First of all, we can decide how we want to install it. We can decide where we install it. Originally, ages ago, a lot of people were installing it globally, because every single project we have locally on our machine, we're using the very same PHP version, let's say PHPUnit version, let's say version 3, and it works for everything. Now we have version 5, 6, 7, 8, and for that we need to be ready to handle different versions for different projects. For that it's better to install the project, the PHPUnit per project locally inside given project folder. Next thing is how to install it. There are two common ways of installing PHPUnit or most of the PHP developing tools. One of them is simply Composer, but other one is FAR. FAR is convenient in that way that we don't have dependencies of dependencies conflict. If let's say PHPUnit was using Symfony YAML component and we were using different version, we got conflict of it, we couldn't install it via Composer. For that, FAR can save from that conflict problem. On the other side, if we are deep diving into PHPUnit, if we are mostly interacting with it, if we are writing our own plugins, we should rather install it with Composer, so we can have properly resolved dependencies, we can have type hinting, we can perform static code analysis. Let's take a look for which PHP engine we can use for given PHPUnit. With every single major bump of PHPUnit, we also bump PHP engine itself as well. Nowadays we bump PHPUnit major every year in the first quarter. But that's kind of boring table. Let's see the vice versa. Usually we have PHP and we think which PHPUnit version we can use. Let's say for PHP 5.6, we would like to use as new PHPUnit as possible, but we cannot use that because PHPUnit depends on concrete PHP engine like we saw on the previous slide. So here we know that the newest PHP we can use, newest PHPUnit we can use for PHP 5.6 is actually 5.7.23. But we can use forward compatible layer and start using it like it would be version 6.4. Same for other PHP engines. So how people are installing PHPUnit? Let's take a look at statistics for April for this year. If you would take a look for stats of downloading the FAR file, we see 170,000 downloads per month with kind of fragmented versions. Still majority of version relying on version 5. On the Composer, it looks way better. It's almost 20 more times downloads, and the majority of users are using nice, good, new version 7. Version 8 was recently released, so not that much time to switch for it. We can also take a look at the trend. First time I was giving this talk, it was almost 2 years ago. The FAR percentage of users, the far downloads were higher, it's dropping now. More and more people are using packages for downloading, so more and more people are using Composer to manage the dependency. At the same time, they install more newest version of the tool. So, we installed the PHPUnit itself. Let's see how we can start writing tests for it. First thing of it is how to structure the test itself on the drive, how to make folders. Classic approach for application is that we simply have two folders, source folder and test folder, everything in source, everything in test, full separation, just two folders to rule everything. For library approach, it's getting a bit more interesting. We have a new trend that we can actually put the test inside of the component. So here we have the component of assets, and this is an example on Symfony. Symfony has its component, each component holds its own tests. With that, whenever we would like to extract something out of our library, out of our application, we can just take full component out. We already have everything bounded to it. We have tests in proper structure. It's super easy to move something away. So now when we know how to structure the folders, let's see how to structure the concrete test file itself. Let's assume we have the super simple source code, doc block representing a PHP doc block. We have two public functions, get annotations and get name, some private helpers to help accomplish those getters. What we can do is to think what kind of tests, what kind of scenarios we can have. We know that we can have empty doc block, maybe we have doc block with just a summary, maybe only annotations, maybe we have everything, or maybe even the test for given annotation will not work properly because the annotation is broken. And here, with this approach, when we think over and over again, we came with more cases, what we would like to test. It's getting more messy. It's hard to maintain, it's hard to figure out which functionality we are testing in given test function. So for that, we can structure the test a bit differently. We remember we got the two source methods, public methods, get annotations, get name. We can have exactly the same matching one-to-one testing methods, and now we know exactly which test method is testing which functionality. On top of that, we remember to not test privates. There's another syntax for it. We can also, instead of giving the test prefix for method name, we can use annotations. But here we have a little gotcha. If we have the name collision, like with the getName method, the getName method actually already exists in our parent class. It has also different prototype, different. It should accept parameter. So for that, the whole compilation will fail. For that, it's safer to always use prefix. It's also what Sebastian, creator of PHPUnit, asks you when you contribute to the PHPUnit itself. But here we saw only two methods, so how to test different scenarios. One solution for that is data providers. So we have our test method for getting annotations, which now accepts different data as input. We can extract concrete scenarios into data provider with 3 different dedicated scenarios for given cases. This approach has an extra benefit that it's actually suggesting people, make it more easy for people to add more and more and more and more cases. Because instead of copy-pasting whole test method, copy-pasting whole setup of how we initialize the service and so, we just give more data scenarios. But when we have only data scenarios, we lost that content, we lost the definition of description of what we are testing. So for that, we can have just a comment explaining what scenario is it. But comment as a comment can get lost, nobody will read it. It's hard to reuse that comment in a code execution, so it's not the best idea to put it only as a comment. So we can actually move it into an array key. So now whenever PHPUnit will execute the scenario, it also knows its description. But here we have another gotcha. We can have duplicated keys. So for that, one of these scenarios would be totally ignored. It's super hard to detect that if we have, let's say, 50 different cases. PHP doesn't help us to detect those duplicated keys, so it's easy to oversee this. For that, we can change and not return an array, but just yielding more and more and more scenarios. Here, when we have duplicated key, it will yield properly again with different value. Benefit of having the keys is also that we can actually filter by them. If we are executing PHPUnit with filter, we can filter not only by class and method name, we can also filter by data provider key. If we would not have a key, we would have kinda crappy output saying that dataset and index of the array got wrong result, that failed. With a nice data key, we actually have proper, easy to understand, easy to find message. But this provides extra thing to remember about. If we can filter by data provider keys, it means that before executing any test in our test scenarios, we would actually execute every single data provider, which means data provider should be as fast as possible. Imagine we would read something from file in data provider. We have 10,000 cases, each of them reads dedicated file. We would have 10,000 I/O operation on hard drive, even if we would filter out to execute only one of them. So for such cases, just keep only file name in data provider and move the heavy logic into the test method itself. Now we know how to structure the folders and file. Let's take a look at assertions. We have a lot of different assertions, assert true, false, whatever. It's kinda boring, so I will not list all of them, but keep in mind that we have over 100 of them. So it's worth to at least go once over this list. This list is closed, Sebastian will not accept any more assertions. He decided that we have enough of them, so we can just learn them once, know that it's there, we don't need to know them by heart, but at least let's have in mind that something exists. Let's go to docs, see how it looks, what the name is. For example, we don't have generic collections in PHP yet, so we have assertion confirming that each item in given collection follow the very same interface. Other example is that we can compare JSON string with a JSON file. So we don't need to provide all the boilerplate of reading the file from hard drive ourselves. We don't need to check does the file exist and so. We have everything encapsulated in assertion. Now the funny part, how we can call the assertion. There are 4 different ways how to call the assertion. First 2 are coming from the parent class we are inheriting from. We can either call it on instance or in static context, or we can call it on assert static class, or we can even call it as a function. Because of this, let's say, cluster pack, a lot of people are using it differently. The best suggested solution are those 2, but not everyone is using OOP even nowadays, and for them they have just calling it as a function. Officially, the test methods are defined as static. So if you are relying on static code analysis, that will actually validate if you are calling all the codes, all the methods properly. It's better to use it in static context, even if most of the cases in the world are using this as a prefix. Now when we call the assertion, most of the cases we have 3 parameters. We have expected value, we have actual value, and we have optional description to be shown if something failed. For most of the cases, the first 2 values, expected and actual value, can be reverted. Everything works. Maybe in case if the assertion was not fulfilled, we will get not handy message error because the values will be reverted, but it's gonna work. But remember that there are assertions that actually rely on the order. For example, if you try to read from the file and we would revert the order of parameters, it would try to read from the file that is actually provided as a JSON, so it will not find it on the drive, it will blow up. So just as a best practice, always put the expected value first. Then, even if we have that 100 plus assertions, those are very trivial, very simple assertions that are generic, that are not testing our business logic. So for us, it may be easier to put business logic as an assertion, encapsulate it once, and don't re-implement it, don't copy-paste it over whole project. So let's say we have an XML document we would like to validate. Is it valid against the schema definition? We can make it as an assertion. The very first step would be simply to create a trait with it and move our logic into assert XSD method, and that's it. Then we can call it from everywhere, as easy as that. This is first step, not the optimal one, let's call it. We can actually make our own constraint. Internally in PHPUnit, every assertion is executing constraint under the hood. What's the benefit of it? When we have the just assertion method, the PHPUnit framework runner count every assertion we have internally and provide it in a total summary how many assertions we executed. If you put it into the constraint, it properly counts whole test, whole assertion as a single assertion. Also, we can provide extra failure descriptions, providing details what exactly failed in our big and complex constraint. Yet, sometimes we don't have any assertions to execute. Sometimes we just want to ensure that our code works properly, that it doesn't blow up. For example, we have our service, we have our action method, we call it, we expect it to not crash. But that doesn't work nicely for us because, sorry, you have a risky test, maybe you forgot to test something, maybe you should have some assertion there. And for that, originally people were handling it, now a bit of history, in PHPUnit 2, early PHPUnit 3, they were just giving dummy assertion. So we ensure that true is true, it's truism. So if you would have not the comment here, somebody would just, yeah, this assertion is pointless, let's drop it. It doesn't bring any value, it just hides a warning. So to be a bit more explicit what we are doing, with free, the new method was introduced that we increase manually counter of assertion. It didn't live long, it was renamed in free, so we can say how big, how much we are counting up the counter. But it's kind of playing with internals of the runner. It's not explicitly saying what we are willing to do, that we are not willing to test anything, we are not willing to assert anything. We just change internal counter and that's it. Nobody knows why. So with 5.6 we have explicit annotation that this whole test is not supposed to run any assertion, and it's fine. So we have now self-describing annotation providing us the details why we are actually not having an assertion here. But as an assertion, it's super easy to just make a typo. So a few years later, it was replaced with a method that will actually crash on compilation if you had any typo. And that's how we can deal with lack of assertions when we expect that the code should not fail, should not crash, should not throw an error. But what if we are expecting to see the error? Again, a bit of history. Originally, no native support, we had to do our own try-catching, we had to fail the test on our side, and it was again not that handy. So again, with version 3, official support for this feature was introduced with annotations, but here it's not only not error-prone for typos. Here we actually don't know which method or which line of our test method was failing. Here, did the constructor throw the exception or the do method? We don't know. If any of them, it's fine. It's not that granular, it's not that strict for us. So soon, with 3.2, setter was created for it. We can now call it from our code. So here, if constructor would fail, we crash the test. Only if the do method would fail, then we count the test as passing. Again, kinda for unification, we don't wanna set internal state of PHPUnit, we wanna expect something. So the setter was renamed and split into multiple methods. Now we expect exception, expect message, expect code, and not just set some internal state. Then, we know how to deal with assertions and errors or lack of them, but sometimes we also have external code, dependencies. Sometimes that external code came from different library, sometimes it's just different service of our package. What we can do with them? We can mock them. Why we should mock them? Because we are writing unit tests. Is it good or bad to mock it? If we write unit tests, we should mock everything. It doesn't mean we should always mock, but it means that we need to be aware that we are not writing unit tests anymore, we are writing integration tests, we are testing not a single class, we are testing class plus its dependencies under the hood. Why it's important? Because of the triangle of tests. The unit tests are supposed to be super fast, super cheap, as much as possible, fail fast approach, and that's it. If we start having integration tests, it's gonna be slower. And nobody wanna contribute to project that run on continuous integration server for half an hour, 2 hours. So as much unit tests as possible. If we need integration tests or maybe even end-to-end tests, it's fine. We can also use PHPUnit for it, but let's be aware what we are doing. So, solutions for mocking. PHPUnit has its own mocking functionality, super old, not changed for over the years. Let's compare it to mock object, mockery, and prophecy, which are external libraries. If we would take a look at same class which we would mock in different frameworks, with mock objects, we are saying that we are mocking the foo class, and get data with parameter key method will return, depends on which call it's gonna be, value 1, 1, or value 2. And then we have the setter. When we call setter with given key, we expect given value as a second parameter. That's it. Mockery. Again, we are mocking foo. We get on getter with given key, we return different values. For setter, similar. PHPUnit internal framework system, internal mocking system, mockery, and mock object works almost the very same way after all the updates over the years. They get somehow unified. What's different is prophecy. Prophecy takes totally different approach. One thing is that we don't say that we will, like here, you should receive get data. Instead of that, we have get data as a method parameter with magic call method used under the hood. And we can say that we expect key as a value, we will return value 1. A bit shorter syntax, but it's just the change that we see on the very first look. The underlying change is bigger. Here we have so-called structure binding. We have structure of our source code we are trying to mock. We know that first call should return something, second call should return again that something, and third call should return something else. Here we don't bind to structure, here we bind to the message. And for that, our key, getting our key will always return value 1, that's it. If you wanna change it, we need to send a message to the mocking framework. So if setter would be called, then getter will return something else. And for that, whenever we change our source code, we don't need to update the mock itself over and over again. If we refactor our source, the mock can remain the same. And especially for that, even Sebastian said that if he would be writing some mocking framework right now, it would look a lot like prophecy itself, for which he introduced prophecy as a dependency of PHPUnit in version 4.5. So it's available basically for everyone now, built under the hood. We don't need to manually install it. It's always there for us. Now, let's hop to other topic. we have code coverage. I assume everyone here knows what code coverage is. We just wanna see how much of our code was covered with tests. So let's see how to groom it, how to squeeze it to take as much as possible from this number. First of all, we have some annotations. Let's say we have the foo test, and we can explicitly say that our foo test is testing only one class, only foo. If it doesn't test anything, because it's not unit test, maybe it's smoke test, end-to-end tests, we can explicitly say it doesn't cover anything. Do we need to do it manually? Yes and no. If you wanna be pure, if you wanna do it properly, you should explicitly write it in our code. If you already have huge existing code base, we can try to automate this process on the fly with coverage listener from Symfony Bridge. It will do it for us. It will try to automatically detect what is the source class, kinda add the annotation on the fly without touching the file. But there's a little gotcha with this listener as well. It actually stopped working already for PHPUnit 8, because listener should only listen to data and not set something, not change internal state of PHPUnit runner. Coverage listener was changing internals of PHPUnit, and now with PHPUnit 8 it's no longer possible. So let's try to run some tests. Let's say we are not yet collecting any code coverage, we just run our tests. We have 12,000 tests executed in 22 seconds. Awesome. Let's try to collect code coverage. Unfortunately, most of the people are still relying on Xdebug extension to PHP, and with it we got 78% code coverage for given project, but it took 30 minutes instead of 20 seconds. So it's not possible to run it on a CI level. Like, we can, but doing it for every PR, it would waste a lot of time. So instead of relying on old Xdebugger, we can actually switch to PHP debugger, which is calculating the coverage slightly different. It's about braces, but the time is way better. Instead of 30 minutes, we have only 3 minutes. And that we can spend on CI level. Now the small interesting part. You remember we get the covers and covers nothing annotations a few slides earlier. What if you would drop all of them? So let's drop them. Let's execute again. Instead of 77%, we have 91%, and it's double the time. Which means, by indirectly testing hard-coded dependencies, we increased code coverage by 15%. It's not 15% for free. It's giving us the false positive number how awesome code coverage is for our project, because under the hood, unintentionally, we tested hard-coded dependencies. So remember about using covers annotations, so we can have good number and we can see what we are not testing in our project. So let's see on the runner itself. We already saw some calls here. Let's see how we can use it nice. In PHPUnit 7.2, some more options were added. We can now control order of execution. We can order by random, by revert, and so and so. With version 7.3, it was unified into single CLI parameter, and now we can say that we are executing our tests in given order. What's the most interesting order here is defect. We can order the tests that were not passing previously first. If you have 10,000 tests like we saw previously, we don't want to wait every single time to see if the last test is still failing or not. We can run it first. With PHP 8.2, we also have duration as a new option. They tried to add it in 7.4, but it was not available through CLI option. So now let's try to use that defects order to have the fail fast approach. To be able to know what test was failing originally in the previous run, we need to catch the result. Only then we actually can take the full value of defect. On that, whenever the first defect will happen, we wanna stop. Originally we had stop on error, stop on failure, stop on warning. Now we have combined parameter to rule them all. And now we see the first execution, blah blah blah, something failed. With second execution, the failing test was pretty fast, pretty soon. Also here we have a little depends. Not that popular, but sometimes people are writing tests that this test depends on another test. If another test failed, we don't want to run the test at all. So here we first run all the depending tests on the test that failed, and then we run the test that failed last time. How we can improve it? With version 8, cache is by default and depends is by default. So we can only say that we order by defects, we stop on defect, that's it. With H2, we can also sort by duration, so if we had only one test failing, then we execute other tests in priority of time. So, let's hop further. How to write testable code. The secret of testing, the secret in testing is writing testable code. So if we have the source code that's not gonna be playing nice with possibility to be tested, we are fucked up. For that, what we can do to avoid that? We can not rely on global states. If we have singletons, also if we have static methods, which are kinda singletons, globals, we cannot mock them. For most of the cases, we cannot even reset their state. So if we have them, we will have issues with unit tests. We don't want to break single responsibility principle, because if we do, then we have got objects. We do too much things in a single class, we don't know what to test, the test's gonna be super huge, so we will forget to test whole functionality. We don't want to have hard-coded dependency, and for that we can start mocking them the best with prophecy. And ultimately, we can start thinking about tests before writing the code. We would follow test-driven development, so we think in advance how we need to structure our code so we can test it atom by atom, unit by unit, and not everything at once. Other thing to have the nice tests is to not rely on legacy versions. We would like to rely on as new version as possible for our project, for the PHP engine we are using. So let's try to upgrade PHPUnit itself. Of course, we don't want to waste time and do it manually. Nobody will like to spend the time on that, so let's try to automate. Maybe a little quiz. Does anyone know this logo? Not that much. Okay. So basically this is a little project of mine, PHP Fixer. With PHP Fixer, we can say that, let's say, we are using the PHPUnit version 5 compatible, forward compatible layer with version 6. We install PHP Fixer and we ask Fixer to update our code base to follow PHPUnit version 6. Now our code looks like in PHP version 6. We don't use annotation anymore, we use the methods. We don't use deprecated ways, we use the new equivalent of them. And then it's not only about version, 4, 5, 6 of PHPUnit. It's also the way suggested by Sebastian Bergman from PHPUnit. It's not only for PHPUnit 5, 6, 7. We can say that we want to install PHPUnit 8. We know that PHPUnit 8 started using strict typing, and it expects test method to not return anything. We need to change the header of every single method we have. So let's run rule for it, and that's it. We don't need to automate every single change in our big code base. We don't need to manually do it, we can automate it. A bit more things from PHPUnit for PHPUnit with PHP Fixer is that it is not only for migration. It's also for having it stricter, for having it always same way to unify it. So example extra rules are that, for example, we always expect annotation for PHPUnit to use fully qualified class names just for consistency. But we can say that we want to have strict comparison, strict assertions of PHPUnit only. So we don't want to use, for example, assert equals, but we want to use everywhere assert same. It's like double or triple equals sign. We want to be strict, let's ensure it on the CI level. And now the quality of test itself. So we can ask when we should start improving our code base. Nothing is perfect, so we can always improve it a bit. When to start? Any day, always. It's always good to start improving. I would even say that it's better to improve unit tests than source code, because if we have only source code, we don't know does it work. If we have unit tests in good shape with a lot of test scenarios, even if source code is not written in a proper, nice, good way, we know that it works at least. So first step would be to start treating source test folder the same as we treat source folder. A lot of people are running static code analysis only on source. Why not on tests? A lot of people are thinking about solid principles when we are writing source, but not when we are writing tests. Other thing is we can keep an eye on deprecations. If we are relying on deprecated features, we would like to know that in advance. We can automate it again with Symfony PHPUnit bridge. It will make it easier for us to maintain big project that lives over time. If you have a 1-month project just to run a dummy website, it's fine. But if you have a project that lives for 5 years, we don't want people to incorporate into our code base a new functionality that relies on deprecated features. We want to use only the new shiny ones, so we don't need to rewrite the feature later. The next level of it would be mutations. There's something called mutation testing. For PHP itself, we have one framework for it, Infection. It can work with PHPUnit or different test runner. And basically what it does. First, does anyone here write or use mutation tests? Perfect. So let's say we have a simple class, a number, that check if given number is natural or not. A trivial test for it, we call the service, we have expectation, number 1 is natural, number minus 1 is not natural. Awesome. What mutation will do is that on the fly, during execution, without touching hard drive, it will mutate our source code. Instead of bigger, it would use bigger or equal sign. And then it would try to run the code again. It would run our test again. And then we see that for our case, let's go back. For our case, for every single test we have, it doesn't matter what operator we have here. The test will be the same. Nothing will fail. Which means we just mutated our source code, and nothing blew out. This is a great indicator that we don't cover edge cases. Bigger or equal is edge case here. We don't cover it. We should add a test case for 0 and decide is it natural or not. So even if we have code coverage, 100% everything good, without mutation tests, we don't know if our line was actually properly covered with tests or it was just executed. The topic is complex. The solution how to do it on the fly is super nice. If you have a bit more time, I strongly suggest you to start playing with it. One warning here, it's slow to execute. It tries to mutate every single line on 20-40 different ways, so it will take time. It's hard to run it for big projects on every single PR, but at least once in a while, it's nice to check if everything's good. A few extra links from this presentation. One of them, CS Fixer itself. Then you remember we got the forward compatible layers between version 4 and 5 and 6. It's built into the PHPUnit itself. If you want to have more forward compatible layers, we can use polyfill, and even if you have installed PHPUnit 6, we can start using features from version 7 or syntax from it. Similar library to it with same purpose as traits which are preventing us for using deprecations, for using something that is not considered to be a good practice. And that would be all from my side. I hope that everyone got at least one nice idea worth to follow in your everyday work. If you have any questions, I believe we have 2 minutes left.
Yes, we have some minutes. Sorry.
We have some minutes left, so don't hesitate to ask it now. If you would prefer to ask it in private, I'm here full day today and tomorrow, so just reach out to me. If you can leave few comments on join.d, it would be great. I would know what to improve for the next time.
Thank you for the presentation. I got a short question about the mutations. I'm quite curious how it will work with some complicated code, as an example. So where the decision is made, what to change, etc. in some short words.
Basically, mutation tests for any language are working on a few steps. The first step is to parse the source code into abstract syntax tree. And then in abstract syntax tree, we know, is it some operand or operator? So if you have the operator, let's say that bigger than or some other operator, we have the equivalence, what different operator we can put here. And then we create a big map, what else can we do? And then we try one by one until something didn't fail, which means mutation survived, which means our tests are not properly handling the code here. For big code bases, like here in the presentation, we saw that little example with 12,000 tests, about 60,000 assertions, if I remember properly. It was PHP CS Fixer itself. And for that, when I tried to run the mutation test for it, it took 3 hours. On iCore 7 and so and so. So for big project, it's super slow because of the whole complexity. Also, it does not change only the operators, like equals, bigger, and so and so. It changes constants. Like if you compare something to 1, maybe let's compare something to 0. If you have condition, if something, let's revert whole condition, if not something. The way to mutate the code, there's plenty of ways for that. And with every single one extra, we double the complexity, how long it is to execute whole tests.
Okay. Thank you very much.
Okay, any other questions?
Okay, then once more, thanks everyone. In any cases, don't hesitate to reach out to me later.